Okay, so we're going to talk about the division algorithm, and I don't usually do this, but I've clipped out the formal definition from the textbook. Some of you may be going on to take more math classes, and sometimes you have to refer to these definitions. So I thought I'd just kind of go through it and show you how we read this type of thing. So it says the division algorithm states that a polynomial dividend, f of x, okay, so that's the dividend, and a non-zero, so it can't be zero, polynomial divisor. Okay, so we're dividing by d of x. So you could say something like f of x divided by d of x. I mean, that's what it's talking about there. That's what we've been doing, dividing polynomials. The degree of d of x, it has to be less than or equal to the degree of f of x. So you can't have like an x cubed plus blah, blah, blah divided by x to the fourth plus blah, blah, blah. That won't work, okay? So your divisor has to be smaller than the degree of the divisor has to be smaller than the degree of the dividend. Or it can be equal to, but that might be a little bit different situation. Okay, so if we have all that, then there are unique polynomials. There's only one way to get an answer here. Q of x and R of x. Now those are polynomials, okay? Now remember, a polynomial can be a constant, but they're polynomials. Okay, and then it follows then such that you have these unique polynomials. If you take the divisor times the quotient and add the remainder, you would get the dividend. And that's what we talked about earlier with the division algorithm. But now you have to think of them in terms of polynomials. Okay, Q of x is the quotient and R of x is the remainder. Okay, the remainder is either equal to 0 or has a degree that's less than the divisor. So if you're dividing along, you're dividing your polynomials, you know, and you get a remainder of x plus 2, then that has to be, so if this is the remainder, then the divisor has to be like x squared plus something, okay? Like this degree has to be less than the divisor degree once you get the remainder. Okay. If the remainder equals 0, and this is a big deal for what we're going to be doing, then d of x divides evenly into f of x. It means your division went in evenly, we say. Okay, and that means that both d of x and q of x are factors of f of x. So let's say you have some polynomial you're dividing. Say you're dividing x plus 2 into, I don't know, x cubed plus 4x plus 4x squared plus some stuff, okay? And then it works out that the remainder equals 0. Then what that means is this is a factor. And we like factors because that tells us things, right? So we've seen that earlier in chapter 5. So we care when the remainder is 0. We care when the remainder isn't 0 also, but we do different things with it. Anyway, I just wanted to talk a little bit about that. Also, if your remainder is 0, that means this is a factor, the divisor, but it also means the quotient up here is a factor. Because if you multiply those, you would get the original polynomial. Okay, that's what the division algorithm says.